Now, the next thing I want to do is take a look at some exceptions to this. So you might think that anytime we see an a value that's not 1, we can just jump into the diamond method anyway and start solving. But that's not really true. Take a look at this example here. This one is above method 2 in your notes. So this time you might think that we can start off with a diamond with 2 times 24 on top, but we don't want to do that. Notice that this time all terms divide by 2. So we should go ahead and divide out a 2. We can undistribute 2, which is going to leave us with an easier quadratic, and then we factored that guy instead. So multiply to 12, add up to -8. And then we should be able to find some factors and go from there. So I neglected to mention that you should always look for a greatest common factor. Is there something I can just divide out first to make factoring easier? Okay, what about when we can't factor a quadratic? What do we do then? Let's say, for example, we have x squared plus 4x minus 7. Okay, this equation cannot be factored. There is no way you can figure out factors of -7 that add up to 4. So we can't use the diamond method here because there are no real rational roots. So in certain situations, we're not going to have easy factors that are findable using the diamond method. I can see on the graph here in Desmos that this does have roots. It is touching the x-axis, but I can't find them using the diamond method. Luckily, we have a couple tools that work no matter how ugly our roots get. Even if our roots are irrational or even imaginary, we can still find the answer using either the quadratic formula or something called completing the square, which I'll do in the next video. So you've probably seen this before. The quadratic formula is a surefire way to always solve a quadratic. -b plus or minus the root of b squared minus 4ac all over 2a. Right, we've seen this before. Now when we say a, b, and c, we're talking about in standard form the coefficients in order. So a, the coefficient of x squared, b goes with x, and c is our number, the constant. Okay, so the nice thing about the quadratic formula is it never fails. It always works. So I'm going to try this out, trying to solve this problem, just replacing x with m here, because that's the variable they chose, or had. And I'm just going to plug everything in. So looking at this equation, a is 6, b is 7, and c is -3. Make sure you're in standard form and everything is moved to one side of the equation before figuring out what a, b, and c are. But now we just plug it in. So I got -7 plus or minus the root of 7 squared minus 4 times a times c. Notice c is -3, not just 3, all over 2a, so 2 times 6. Okay, so we've got the answers. Those are the answers. We just have to clean them up so we can actually know what they are. So this can take a little bit of work. Quadratic formula can be a little bit tedious, which is why I like completing the square a little better, which we'll talk about in a second. Okay, 4 times 6 is 24. 24 times 3 would be 72. This is going to turn positive because we have -4 times -3. And all over 12. All right, 49 plus 72. We've got 121. That's convenient. That is a perfect square, so that's going to work out nice. All right, 121, that's 11 squared. So we've got -7 plus or minus 11, the square root of 121, all over 12. Okay, we're almost done. So far, we've been using this plus-minus symbol, which is just a way for us to be lazy. Instead of having to rewrite this whole formula once with a plus sign and once with a negative sign, we just do this as far as we can to save ink. But at this point, we need to get our two solutions. So I'm going to split this up into the positive version, -7 plus 11, and the negative version. So we want to hold on to that plus-minus to save us some time until we need to get to the end. Okay. Here I have -7 and 11 make 4. So this is 4 over 12, which is 1/3. So there's one answer. And then I've got negative 7 minus 11, so that's negative 18 over 12, or negative 3 over 2. Yeah. Okay, in the next video, we'll do this similar problem, but by completing the square.